final example, solving for net force in 2 dimensions. We're given a question. We have 2 children pulling a sled. One child uses, the first child uses this much force. Charlie's snoring again. The second child pulls with this much force. Okay, and so this, by the way, will be more of an example like the tractor question, but now we have everything unequal and on different angles. So we want to find the net force on the sled. I think there's, negligible friction. Okay, so because there's only the 2 forces, I can use the sine and cosine method easily. Okay, so I'm going to show you how to solve the problem using both strategies. And similar to the last one, I'm going to break it up down the side. So the left side page will be just the sine cosine, the right side will be the x and y. So we're looking for net force with no friction, but 2 forces on different angles. Let's get rid of this thing. Okay, so looking at the sines and cosines, it is just the vector sum. So I take these 2 forces and I make a triangle and adding them. Okay, so a great line, I probably told you this before, but Mr. Markle, who is my mentor, said, there's only, about physics, there's only like 5 things I know, I just know them really well. And to get through this course, if you get really good at vector addition, which is kind of the same as vector subtraction, that's like one thing. Understanding the basics of gravity and net force is another thing. There's not that many things you need to know to be good at physics, and one of them is vector addition. Okay, so here we go. The net force is the vector sum, so here we go. And I just, by the way, so I don't draw this thing out every time, I'm just saying little f is my resultant force. So let's just look at the triangle. So F1 is 15 newtons north, 35 degrees east. So there's the north right there. So it's 35 degrees east to that, and it's 15 newtons. There's my first vector. Then I add to that the second vector, 25 newtons, so it should be bigger in size, and north 54 degrees west. So there's my north, and that's 54 degrees west. Okay, so there's the numbers that are relevant. Looking at the different angles, just in this little bit right here, if this is 55, that's got to be 35. Using the Z rule, follow my cursor here. Using the Z rule along here, if this is 55, this has got to be 55. All right, and then this is 36, and that 36 is sort of from the horizontal up, because this is 54, and those two have to add up to 90. Okay, so that gives me an overall angle of 91 degrees in there. Now I'm solving for F. Cosine law, exact same as we've done several times. Use the sine law to find this angle here. I end up with 58 degrees. Therefore, my overall is 23 degrees west of north. Why is that? Because this whole bit has to add up to 58, okay? 58 minus 35 is my 23, and that means that's this little bit right in here. So that's how many degrees west of north I am, because there's the north, and I'm 23 degrees west of it. Okay, so that's my answer. And if you think about net forces, does that make sense? If the overall force, it should be fairly north, because they're both pulling in the north direction, right? But he's pulling, or he or she's pulling east, this one's pulling west, so it's going to be more of a north result. And 28, I think, it's within the realm of the right numbers. It's hard to say, but it's not out there. It's not like 10 million. So because it's not 10 million, I'm putting a check mark on it. Okay, same question using x and y components. By the way, if you feel confident, you should try this on your own and then check my answer and see if you got it right. That would be awesome. But if you're not feeling confident, here she is. So same idea as last time, or first example, find net force in the x direction, find the net force in the y direction, make a right angled triangle, and use Pythagorean theorem. Okay, so looking, again, breaking up my thing here into x and y. In the x, the net force in the x is the first kid plus the second kid horizontal components. And on the y is first and second. Okay, add them up. So would have had to declare a positive direction, which in this case I'm saying up and west, north and west, sorry. North and west. So the first is 15 in the x direction, 15 cos right? Because it's adjacent to the angle, so cos 55. And in this one, it's cos 36, right? Notice I made this negative. I made it orange just so we wouldn't forget, because I called west positive, and this one is east, right? It's moving in the east direction. That lets me solve for my net force and my x direction. The y direction, that's a terrible right angle triangle now that I look at it. But anyway, we said north was positive, so they're both going to be positive because they're both moving up. And it's sine 55. It's across from 55, so it's sine. And this one's across from the 36 degree, so it's sine as well. So you just add those up. So that's my net force in the y direction, or the north direction. And then I can make my right angle triangle. So this is positive, which I said was west, so it goes this way, 26.9 up. Solve for f using Pythagorean theorem, about 29. Solve for the angle, and it works out to 67. So it's 67 degrees north of west. So 29, so I got about the same answer. That's good. And this one was 23 west of north, 67 north of west. Adds up to 90. That sounds like it makes sense. You still hear Charlie snoring? Okay, so that's it. That's net force in two dimensions. You should try a few of your assignment questions on those. Good luck.